All right, this is a good example actually to talk about critical values. It's pretty straightforward on the Google Sheets. Let me, in fact, just grab that. So this is a hypothesis test, and trust me, I'm doing stuff that you can't see on screen yet. And so let's, do this here, do that there. All right, so I have a hypothesis test on my Google Sheets. This is the data list tab. You can see it's under a T distribution. How do I know to use a T and not a Z? Right here, you have a sample standard deviation. You do not have the population standard deviation. If it was a population standard deviation, then you would use a Z. All right, so this part I think is pretty straightforward. There is the test statistic, but now this question actually asks you to find the critical value. So remember what you're even doing when you're, so let me make my T distribution curve, kind of looks pretty good. My hypothesis test is 3.3. This value is 3.31. So what you're doing is you're standardizing that to 0, and then you want to know what this value would be, okay, this 3.31. But what I can do is based on somewhere right there, looking for it, I can find the critical region. Remember what the critical region is it's where you would cut off, okay, if you don't believe what they're trying to tell you. So if this is 0, once again, my test statistic, I've standardized right there to 0.74, the way they show it rounded. What I want to know is if I'm cutting off 0.01, and I'm just guessing it's out here, I don't really know where it is, I want to know what that value is. I want to see, did my test statistic fall in that critical region? Now, here's the issue with critical values that students have a hard time with. Notice this is a two-tailed test. So what that means is if I just draw out to find my, I know it's ugly, that's a normal curve, my critical value, if what I'm cutting off is 0.01, that's actually both here and here. Sorry, my arrow didn't get very well because it's a two-tailed test. So this in the middle here then, if that's 0.99, well, that doesn't add up because that's over 1. So what you actually have to do is divide both of these by 2. And this is important because you're going to wonder, where did she get this next value? All right, so to find, in my case, this example up here, these need to be divided by 2. And the reason is because this is a two-tailed test. So what I actually have to look up or use in my formula is up to that critical value. Same thing, just kind of I wanted to put the 0.99. So I think that would actually be 0.005 plus 0.99. That's going to give me 0.995. And that's important because I'm going to use this number in my formula, and you're going to be, but why is she using that? Because of the picture. And so what is my formula? You can actually just go in a blank cell and type T.INV, put your probability, and then put the degrees of freedom. The degrees of freedom is the sample size minus 1. And so you'll see that I did that. In fact, I actually did it on another tab. It didn't really matter where you have it, right here. So I put all those values in here. I wasn't sure what I was doing yet. And what I did is I created a formula. I don't know why I have a X. That would probably be my T. In fact, it'd probably even be better to say my critical value. But notice what I have here. Okay, so notice in this cell, I actually have 1 minus 0.01 divided by 2. Why? The entire curve has to add to 1, and then I subtracted out. What I actually subtracted out is this area right here. I know I'm all over the place and this is probably confusing, but you have to get the 0.995 down first. That's the most important part. So then in your formula here, my T inverse is my 0.995. In fact, I kind of did over there. Let me retype it again so you can see it. T dot INV 0.995 comma 34, my degrees of freedom, and it gives me that answer. It's just I'm too lazy to do this over and over, so probably if I was really smart, what I would do is I would make a cell somewhere, you know, whether you want to do it on this page or wherever you want to do it, and just say these are going to be my critical value. This is alpha 0.01. I know that I am going to need alpha divided by 2, so equals that divided by 2, and this is, I'm sticking with my T, and so then the total area in this case is going to be 1 minus the alpha divided by 2 that you saw me do. That's how I got the 995, and so now my critical value equals T dot INV, this, comma, my degrees of freedom. And the reason that I'm doing this is what if now, oh, they want me to do 0.05. They want me to do 0.02. And so I've made a nice little formula here in my, what do you call this, Google Sheet? I started to call it Excel, just to be able to calculate this. But probably the bigger part of this was to really explain this picture of why when you have a two-tailed test. Now, if this was a one-tailed test, you didn't have to do that, right? You could have used the 0.99. But this is a two-tailed test of why I'm putting the 0.995 in.